All right, looking at 8.4 multiplying radical expressions. This will be a pretty quick one. It's kind of the opposite of the product rule with radicals. If I have something like the square root of 3 times the square root of 7. Earlier, we said that if we have the square root of a times b, that we can separate that into the square root of a times the square root of b, right? So just like I've mentioned it a lot, that equal sign means a lot. This side is exactly the same as this side, it just looks different. So if the square root of a times b is equal to the square root of a times the square root of b, then that means the square root of 3 times the square root of 7 can be brought under one radical. All right, so this side is like that, this side is like that, and because they're equal, I can do that. I can break them apart if it benefits me, or I can bring them together if it benefits me. Whichever one helps me the most is what I'm going to do. So I'm going to get the square root of 21. 21 has no perfect square factors, so at that point, I am done multiplying those two together. All right, if we have something like the square root of 10 times the square root of 2, that would be equal to the square root of 10 times 2, which is the square root of 20. This one I can't say I'm done yet because that one I can reduce. The square root of 20 is the same thing as the square root of 4 times 5. So just like this whole chapter, that list of perfect squares is coming back. It's going to be important you have those memorized. That 4 comes out as a 2, and I'm left with 2 square roots of 5. All right, so when I'm multiplying radical expressions, I'm just bringing them all under one radical, getting whatever I'm going to get for a product in my radicand, and then reducing it or simplifying it. All right, let's look at one that maybe looks a little more complicated. Okay, if I've got square root of 12 times the square root of 5 times the square root of 10. I'm going to put them all under one radical. I'm going to get square root of 2 times, or 12 times 5 times 10. 10 times 5 is 50. 50 times 12 is 600. All right, I could have done 12 times 5 is 60. 60 times 10 is 600. 12 times 10 is 120 times 5 is 600. Whichever way you can work that better. I know that 600 is the same thing as 100 times 6. 100 is on my perfect square list. So that's going to come out as a 10. And I'm going to be left with 10 square roots of 6. Alright, so if there's 3 factors, no different, bring them all under, as long as the index is the same, it's all like radicals, or same index anyway, I can bring them all under one. Alright, let's get some algebra involved, let's throw some letters in there. I've got negative 3 square roots of 20x times 4 square roots of 6x times the square root of 18x. All right. There's 2 ways I can do this. I personally like smaller numbers better than bigger numbers. The example in the book is just going to straight up multiply 20 times 6 times 18, x times x times x. I'm going to reduce each one of these numbers first. I'm going to simplify these radicals and then I'll do it. That way I'm dealing with smaller numbers. I know that this is the same thing as negative 3, that's going to be 4 times 5x, because 4 is a perfect square, I can pull it out, times 4 square roots of 6x, nothing I can do with that 6. 18 is the same thing as 9 times 2x. So I can pull this 4 out as a 2. That's all stuck under there. This is going to come out as a 3. 2 times negative 3 is negative 6 square roots of 5x times 4 square roots of 6x times 3 square roots of 2x. Alright, I could have multiplied 20 times 6 times 18 and I would have got 2,160, and then I would have had to reduce that. It's just easier to me to go ahead and do it while they're small. Now I can combine negative 6 times 4 times 3. So negative 6 times 4 is negative 24, times 3 is negative 72, times the square root of 5x times 6x times 2x. That's going to be negative 72. Square roots of 5 times 6 is 30, times 2 is 60. X times x times x is x cubed. Now, one factor of 60 is a perfect square itself. I know it's 4 times 15. So, negative 72, 4 times 15, x cubed. My index is a 2, so I'm going to break that into x squared times x to the first. I don't always show the first, but this one I will. That 4 comes out as a 2. That x squared comes out as an x. Negative 72 times 2 is negative 144. The x came out, times the square root of what's left under is 15x. Alright, 15 can't break, it's 3 and 5, none of those are perfect squares. X, I can't break it down any smaller, that's as far as I can go. Alright. Let's do a distribution. Say I have 3 square roots of 2 times the quantity of 5 plus the square root of 3. Just like anything else, whenever I have 2 factors here, I have 3 square roots of 2, and I have 5 plus the square root of 3. I'm multiplying these two things together. Anytime I have something outside of a set of parentheses, that red flag needs to come out that I need to distribute that food. So I'm going to multiply it times 5. 5 times 3 is 15 square roots of 2. 3 square roots of 2 times the square root of 3 is going to be plus 2 square roots of 2 times 3. So I'm going to get 15 square roots of 2 plus 2 square roots of 6. Then I got to check and see, I said 2 is 3. 3 times 1 is 3. Gotta be careful to make it easy, cheesy mistakes and miss the whole thing. Alright, so 3 times 1 is 3. 3 carries down. I gotta make sure 6 won't reduce to make sure they're not like radicals. No perfect square goes into 6, so that one's as far as I can take it. So it's really not that bad. Just treat it the same as any other time we have something outside of a set of parentheses and distribute it. Alright. What if I have 2 binomials? Let's say I have 3 plus the square root of 2 times the quantity of 5 minus the square root of 3. Alright, so how do I handle multiplying 2 binomials? Always the same. FOIL, first times first. 3 times 5 is 15. Outside times outside, 3 times the negative square root of 3 is minus 3 square roots of 3. Inside times inside, the square root of 2 times 5 is plus 5 square roots of 2. Last times last. A positive times a negative is a negative. The square root of 2 times 3 is the square root of 6. Alright, do I have any like terms that I can combine? I've got 15, I got a constant, I got a square root of 3, a square root of 2, and a square root of 6, so I've got no like radicals, no like terms. There's nothing left that I can do with those. Alright, so we're done there. Make sure I didn't miss anything here. let's look at, you've seen these before too. Let's look at one like the square root of 2 minus the square root of 5, the square root of 2 plus the square root of 5. Alright, we talked about these when we were multiplying binomials. They're exactly the same except for the sign in the middle is different. Those are called conjugates. When we learned the FOIL method we talked about, when we multiply two conjugates times each other, we're still going to FOIL, but we get to ignore the O and the I part. Because ultimately, when I multiply the outside times the outside plus the inside times the inside, when I do conjugates, they're always going to cancel each other out. Because the square root of 2 times the square root of 5 minus the square root of 2 times the square root of 5 will always cancel. So all I've got to focus on when I recognize that the conjugates is the first times the first and the last times the last and simplify. So square root of 2 times the square root of 2 is 4. Negative times a positive is a minus. The square root of 5 times 5, or the square root of 5 times the square root of 5 is 5. 4 minus 5 is negative 1. Alright? If you do the outside times the outside and the inside times the inside, you'll still get the same answer, you just have extra work. They'll cancel each other out every single time. Alright. Let's look at that again. I put 4. The square root of 2 times the square root of 2 is 2. Minus the square root of 5 times the square root of 5 is 5. That's negative 3. Alright, so I got the rush, and I kind of messed up, and I put 4 when it should have been the square root of 4, which is 2. Gotta be careful. No matter how many of these you've done, you get in a hurry, you can make the same cheesy mistake. I could redo this and then edit out that, but all of us make those mistakes. You need to see that we do it too. Alright, so let's look at something like 4 square roots of 2 plus the square root of 3 squared. Well, all this means is to take this binomial and multiply it times itself, right? So this really should be review, it just looks different because it's got radicals instead of just variables. Now I'm going to FOIL. 4 times 4 is 16. The square root of 2 times the square root of 2 is, I'm just going to leave it like this for now so you can see it a little bit better. Outside times the outside, 4 times 1 is plus 4. Square roots of 2 times 3 is 6. A positive times a positive is a positive. The square root of 4 times the square 4 square roots of 2 times the square root of 3 is 4. Square roots of 2 times 3 is 6. Positive times a positive is a positive. Square root of 3 times the square root of 3 is 3. The square root of 4, this just becomes 16 times the square root of 4 is 2. These two are like terms. 4 square roots of 6 plus 4 square roots of 6 is 8 square roots of 6 plus 3. 16 times 2 is 32 plus 8 square roots of 6 plus 3. 32 plus 3 is 35 plus 8 square roots of 6. Alright, nothing new, just looks a little different because we're dealing with radicals instead of variables. That's it for multiplying radical expressions.